In this lecture, we'll see how we can use an audio manager to support more complicated audio processing. For example, when a game object is destroyed, an audio source attached to that game object is also destroyed. So if we have game objects playing death sounds as they're being destroyed, we won't actually hear them because their audio sources are getting destroyed at the same time. This lecture covers the sound portion of a Feed the Teddies game that we'll cover more thoroughly in the next course in the specialization. Let's go take a look. One common approach to doing audio in games is to attach an audio source to the game object that sort of conceptually makes that sound. There's a problem with that approach in this particular game and in general. So let's think about the explosion, for example. The explosion would be the appropriate place to add an audio source to, and once the explosion's animation ends, the explosion destroys itself. The problem is that the audio source attached to the explosion game object is also destroyed, as it should be, but if the audio clip for the explosion hasn't finished playing yet, then it sounds cut off because it's been cut off. And I've also run into this problem with an asteroids game where an asteroid gets hit by a bullet. They're both getting destroyed. Something should make a noise, but neither one of them can because it's been destroyed. A good general solution to that problem is to have a single audio source that will play all the audio in our game, and then have an audio manager that uses that game audio source to play the audio. And that's the approach that I've used in this game. You can see the scripts that I have are audio clip name, audio manager, and game audio source. And I also have a game audio source object added to the game. And the only thing it has at this point is a transform and the game audio source script attached as a component. So let's go look at the code to see how all this audio stuff works in this game. Remember that the game audio source script is attached to the game audio source game object. In Awake, we make sure we only have one of these. So we don't want multiple game audio source game objects in the game. And this could happen if we left the main menu and then came back to the main menu, because when we came back to the main menu scene, another game audio source object would get added to the scene. So here's where we check that. And what keeps track of whether we've got one or not is the audio manager script will tell us whether or not it's been initialized. If it hasn't been initialized, then this is the first game audio source object we've added to the game. So we do a number of things. We add an audio source component to the game object. We call the initialize method with that new audio source, and we call this method built into Unity called don't destroy on load. And we pass in the game object we want to persist across multiple scenes. So if you call this method, you actually get that game object throughout the scenes in your game until you decide to destroy it. And that's a good thing because we want the audio in every scene in our game, not just in one. If in fact we already have a game audio source object, we just destroy the one we're creating here as we enter the main menu because it's a duplicate. Audio clip name is just an enumeration of all the audio clip names that we're going to play in the game. And then the audio manager ties all this together. So it has a field to tell whether or not it's been initialized. It has an audio source field so it can save that audio source. And then it has a dictionary. So these dictionaries are really useful. We've seen them all over the place in this game, and they are generally really useful in game development. This dictionary is keyed by the audio clip name, and the value is the clip for that audio clip name. Here's that property that tells whether or not we've been initialized. Here's the initialize method. So we set the flag to true so that we know we've now been initialized. We set our audio source field to the parameter, the argument that was passed in from the other side for our audio source, and then we add each clip to our dictionary. So here's the key for this particular audio clip, and then we do this runtime loading of a resource that we've seen regularly as well. So we load all the audio clips, and what's nice about using this dictionary is if somebody decides that burger damage isn't the right name for the actual file that we're going to play, I use WAV files, but Unity supports a variety of different audio sources, then all you have to change is this name here, and nothing else in the game has to be changed. And that's nice, so it protects the rest of the game from file name changes when somebody decides to change the name of a WAV file. And now, at this point, when we're initialized, we're holding the audio source in a field, and we have our dictionary loaded up with all the clips that we might play as part of the game. And the last piece of the audio manager is this play method that other classes in our game can call to play a particular audio clip. And the way that works is it looks up the audio clip in the dictionary using the audio clip name that was passed in, and then it calls play one shot on the audio source object. Now, you may have seen audio played with the play method, and that's great, it's awesome, but play one shot is sort of a fire and forget way to play audio clips. So having a single audio source play all our clips, we certainly want them to be able to overlap and so on, so we can't sort of tie up the audio source with a single clip to play to completion using the play method on that audio source. Instead, we call this play one shot, and it starts up that audio clip and then it's ready to play some more as necessary. So that's why we want to use play one shot with our single audio source in the game. So we can see who calls this play method. The burger class calls it 3 times, explosion calls it once, and so on. There are 16 matches, including the definition of the method, so this method is called 15 times by multiple objects in the game to play our audio. And that's all there is to implementing the audio for the Feed the Teddies game. To recap, in this lecture we saw how we could build a simple audio system using a game audio source and an audio manager. We saw how this made it so that none of the game objects actually needed to have an audio source. And we also saw that this lets us play sounds when having a game object play that sound wouldn't really work well.